Hello everyone, my name is toadoum.sari, Data Science and Business Analytics intern at Spark Foundation, an institution that offers a graduate rotational internship program that aims to offer students and recent graduates gain skills by working on specific tasks and build credible and professional profile. The link to apply will be in the description of this video. So today I will present the task 2 of my internship, which is a prediction using unsupervised learning machine learning. The aim is to predict the number of optimum cluster using iris dataset. That is the popular machine learning dataset that we use most of the time to learn. So we will first of all present the explanatory data analysis, then create our unsupervised learning data, following by the k-means clustering and getting a good number of cluster, and we will end with model evaluation. We import first of all libraries to use. Our dataset have 4 features: sepal length, sepal width, petal length, and then petal width. Species is the target variable. We drop the target variable. We drop the ID variable because it's not an important feature. Here we are trying to check if there is a missing value in our dataset, and our dataset don't have missing value. So the describe function here give us the summary statistics, which is important to know if we need to scale our dataset, because sometimes some of our features can have high variances, so we need to scale them in order to give a dataset that will help our model to have stability when we are trying to train. Here we are trying to use the pair plot for the visualization. The pair plot is a plot which gives the distribution in diagonal and the relationship between the two features based on the target. So you will see that each of the feature that we have 2 by 2, we are trying to, the pair plot is trying to give the relationship between them based on the target, which is iris setosa, iris versicolor, and iris virginica. We also use t-SNE, which stands for T distribution stochastic neighbor embedding, and help to visualize data from high dimension to low dimension, because we have 4 features here. And the plot show that we have, like, in reality 2 classes, because this one is this first class is far from the 2 others. So the 2 others are like mixed, so it's like in reality we have like just 2 classes. Here we are trying to create our data set without spices to use for our supervised learning model, because there is no label or target in unsupervised learning machine learning. So in supervised learning we don't have target, and we are trying just to learn based on the feature to have targets. That's the aim in unsupervised learning. So here we are using k-means algorithm. So what is k-means? So k-means is a type of machine learning algorithm that have many examples in real life. For instance, when we want to wash our clothes, we take into account some parameters. So like we pick, for instance, one cloth and then add others that have the color that is close to one that we pick randomly, and we can like end up with a set of 4 clothes to wash. So these are clusters, and the one that we pick randomly is like our centroid of clusters. So basically, k-means will cluster data into k group where the value of k is predefined. At random, we will select total k point, which many or not be from the dataset. So which will be known as the cluster or centroid. Then we assign the data point to their closest centroid based on any distance function. And then we will repeat the step of maximization, or the step where we assign the data point to their closest centroid based on any distance function until the data point move from the previous clusters. You should also note that k-means aims to place cluster in the way that minimize the inertia. So here you realize that there is inertia here because we are using elbow rule. So what is inertia? Inertia here is the measure of how spread out the clusters are. So a good clustering has tight cluster, which means low inertia, but not too many clusters. A good rule is to choose an elbow, as we are using elbows here. So a good rule is to choose an elbow in the inertia plot, which means the point where the inertia begin to decrease more slowly. So based on this plot, we have where the inertia is as the plot is decreasing like this, and then based on the number of clusters, we see that here the number of clusters is 2 and then 3. So 3 here will be a good choice based on this plot, because when we are at 3, we see that the inertia starts the inertia begin to decrease more slowly. So since we have the number of our cluster, because here 3 will be the good number of cluster, so we will try to plot. Now we are trying to check by plotting our k-means result with different number of cluster. Here we have k equal 1, this part of plot k equal 2, and then this part of the plot k equal 3, and here this part of code we will try to plot our normal data that they give to us before with the spices, which is the target. So we are trying to plot this one, our prediction based on clustering with different number of cluster to see which one is the best. So after doing this, we realize that our k-means algorithm work fine when we have k equal 3. So we realize that for the number of cluster equal to 3, we have a result close to the real data that we have before. So the same thing we have got using elbow rules. So remember that when we were using elbow rules here, we say that this number of cluster 3 is the best one, because at this point we realize that the inertia started decreasing slowly. So that's why when we are trying to double check here, we realize that with k equal 1, k equal 2, you need to understand that here k is the number of clusters. So with the number when we take number of cluster equal 1, number of cluster equal 2, number of cluster equal 4, and then equal 3, the result that is really close to our original data set is the one with the number of cluster equal 3. This one is the plot for the original data set. So now we have to evaluate our model if our model that we are using is predicting well. So using cross tabulation, we realize that this one is the cross tabulation that we are using to evaluate our model. So this one is a label, and then our k-means here are spices: iris setosa, iris versicolor, and then iris virginica. So based on this cross tabulation, we realize that k-means fell on 6 data points, because here we have 2 data points for iris versicolor that is predict wrongly, and then 48 that is well predicted, and then for iris setosa we have 50 that is well predicted. There is none of iris setosa that are wrong predicted. And then for iris virginica we have 36 that are well predicted, and then 14 that are not well predicted. So 14 plus 2, it means that we have 16 data point over 150 data point that are not well predicted, which means that we have roughly 50% well prediction. So clustering iris setosa is easy, and our t-SNE show us. If I came back here on the t-SNE plot, we see that iris setosa is alone here. So it's like our model, our k-means model predict easily the iris setosa spice. So the 14 mistake out of 16 come from iris virginica, which show that it is hard to cluster them, and our visualization using t-SNE show that there is a mix somewhere between virginica and versicolor. So that's the result that our model gives. Thanks for watching, and stay tuned for more tasks. Thank you.